Hello everybody, welcome to session 2 of chapter measurement. The objective of today's video is to define length, mass and time, to calculate area and volume of regular and irregular objects. Define standard length, or we can also call it 1 meter length. There is one organization called International Bureau of Weights and Measures in Paris. A bar or rod is kept made up of alloy of platinum and iridium, having two golden lines at the ends. One golden line here and another golden line is here. And the gap between these two golden lines at 0 degrees Celsius is known as 1 meter length. So here why we specify temperature is, you know that if the temperature increases or decreases, the gap between two golden lines can be different. So to make it standard, the temperature is also fixed. And to measure length, different units are used. For example, to measure a small length or distance, units like centimeter, millimeter, micrometer, and nanometer are used. Similarly, to measure the gap between two molecules or two atoms, the unit like angstrom unit is used. To measure large distance like the distance between two places, unit like kilometer is used. And to measure really a very large distance like distance between two heavenly bodies in space, units like light year or astronomical units are used. Define a light year. As I told you, light year is the unit that is used to measure the distance between heavenly bodies in the space. So what is one light year? Suppose this is one heavenly body and this is another heavenly body, and the light that is emitted by this heavenly body, if it takes 1 year to reach here, then this distance is called one light year. Similarly, the light which is emitted by this heavenly body, if it takes 2 years to reach here, then the gap between these two heavenly bodies is known as 2 light year. And if you want to represent 1 light year into SI system, means meter, then we need to take the help of formula distance equal to velocity of light in space into time. So distance value is 1 light year equal to velocity of light in space is 3 times 10 to the power 8 meter per second into time is 1 year. Now we are converting into SI unit, means this 1 year we have to convert into seconds. So for that, if you multiply by 365, it turns into days. If you multiply by 24, it turns into hour. If you multiply by 60, it turns into minutes. And if you multiply by 60, it turns into second. And this second will cancel. So if you multiply all of these numbers, then the ultimate answer is 1 light year equal to 9.46 into 10 to the power 15 meter. So this is the value of 1 light year in SI unit. Similarly, if you want to define astronomical unit, then the average distance between Sun and Earth is known as astronomical unit. And the SI in SI unit, 1 astronomical unit means 1.49 into 10 to the power 11 meter. Mass. So every body is made up of molecules, and according to the number of molecules, the body has mass. So if a body has more number of molecules, then it will have more mass. If the body has less number of molecules, less mass. And since mass is made up of molecules. So mass is defined as quantity content of a body is known as mass. And it depends on number of molecules of body, because with the changing number of molecules, the mass of body can be different. That's why it depends on number of molecules of body. And mass is measured by beam balance, or we can also call it physical balance. And SI unit of mass is kilogram and CGS unit is gram. Other units of mass are ton, quintal, milligram, etc. And the relation here you can see 1 ton will have 1000 kg, 1 quintal means 100 kg, and 1 kg means 1000 gram, and 1 gram means 10 milligram. What is standard kilogram or 1 kilogram? In International Bureau of Weights and Measures in Paris, there is a cylinder. You can see a cylinder, and this cylinder having diameter and height equal. And this cylinder is known as 1 kilogram mass. The gap between two events is known as time, and time is measured by watch, and there are four types of watch. Let's discuss one by one. Mechanical watch or automatic watch, or it is also known as pendulum watch, because the time is measured here by the oscillation of pendulum. Quartz watch, the watch which measures time by counting the vibration of quartz crystal. So these are the example of quartz watch. So inside here quartz crystal is kept, and the time is measured by vibration of quartz crystal. Electronic watch, and the electronic watch, it measures time by counting the frequency of AC current. And lastly, atomic watch. This watch measures the time by counting the frequency of electromagnetic radiation that is produced by cesium atom, is known as atomic watch. And among these four watches, the accurate time is given by atomic watch. And what is the one more advantage of atomic watch is that it can measure even microsecond. Zenith. So if you stand anywhere on the surface of the earth, then the point that is just above your head, that point in space is called zenith. So that's why zenith is defined as a point in space vertically above the observer's head is known as zenith. And it was used to measure time in ancient time. What is solar day? So here, this is a zenith, and suppose today sun passed by this zenith, and tomorrow the time taken by sun to come tomorrow at the same point on the zenith, that time is called solar day, and it comes tentatively 24 hours. That's why one solar day equal to 24 hours. And if you convert into second, then it comes 86,400 second. And if we change the sides, then 86,400 seconds equal to one solar day. Hence, 1 second equal to 1 by 86,400 of solar day. That's why if anybody asks you what is 1 second, even you can say that 1 second is 1 by 86,400 of a solar day. Area. The surface occupied by any object is called area, and its SI unit is square meter and CGS unit is square centimeter. An area of regular plane can be obtained by using formula like if you want to calculate area of rectangle, then the formula is length into breadth. If you want to find the area of triangle, then half base into height of triangle. If you want to find the area of circle, then pi r square. Here r represents radius of the circle. To calculate the area of a sphere, we can use formula 4 pi r square. And to find the value of area of cylinder, we can apply formula 2 pi r h, where h represents height of cylinder. To find the area of irregular surface, we need to take the help of graph paper. For that, keep that irregular surface on the graph paper and draw the outline by the pencil. After that, count the number of complete and incomplete squares and add them all, And later on, what you do is find the area of one square and multiply by the area of that one square into total number of square. In that way, you can find the area of irregular surface. Volume, the space that is occupied by any body is called volume, and solids and liquids, they have fixed volume, but gas has no fixed volume. And the SI unit of volume is cubic meter, and CGS unit is cubic square centimeter, and volume of liquid and gases is expressed in liter. So 1 liter has 1000 cubic centimeter. As area, volume of regular objects can be obtained by using formula. For example, if you want to find the volume of rectangular block or cuboid, then formula is length into breadth into height. If you want to find the volume of cube, then formula is L cube. To find the volume of sphere, formula is 4 by 3 pi r cube, radius cube, and in diameter 1 by 6 pi d cube. To find the volume of cylinder, formula is pi r square h, and to find the volume of cone, formula is 1 by 3 pi r square h. So these are the formula by which we can find the volume of regular objects. But to find the volume of irregular objects, we need to take the help of measuring cylinder along with the liquid inside. So here we have taken measuring cylinder with the liquid inside up to level A. And to find the volume of irregular stone, we immerse it. After immersing this stone into the liquid, the level of liquid will rise up to C. So the difference in this level will give the volume of irregular stone. We apply power of 10 in order to represent large number into small form. Like here you can see these are the large number here you can see, and by using this method we can convert this large number into a small number. Like here see you can convert into small form, so it will be easy to write, easy to read. So for that we have two methods. If you take a decimal back, then the power of 10 we always represent with negative, and if you bring the power decimal in front, then power of 10 we represent by positive. Here, for example, here we are taking decimal from here to here, because decimal always we take behind one real number. So if we take decimal here, then it turns into 2.36 into 10 power. Here already we said when you take back, power will be negative. That's why negative. But how much back we have taken? Let's count. 1, 2, 3, 4, 5, 6. That's why power minus 6. Here, decimal now will be taking from here to here. So decimal is going after 5, and after 5 there is no any number. That's why we just write 5 into 10 to the power minus. And how much back we have taken? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why power is 10. Another example now we want to discuss. So in these cases, we are taking decimal in front. So when you take the decimal in front, the power will be positive. So here nowhere decimal means decimal is at back. So you are taking decimal from here to one real number, after one real number. So how much in front we have taken decimal? Is count. From here to here means count 1, 2, 3, 4, 5, 6, 7, 8. That's why power is 8. Similarly here, decimal is you are shifting from here to here. So if you shift decimal from here to here, then it becomes 6.000. So after decimal 0 does not have any meaning. That's why we are just writing 6 into 10 to the power. How much in front we have taken? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why power is 9. In this way, we can represent large number into small form. With this, we want to wrap up session 2. Thank you so much.